Hi friends, today I am giving a lecture on what is algebraic system and what are the general properties of algebraic system. These are the points that we are discussed in this video. First of all, what is algebraic system? Algebraic system means a system consisting of a non-empty set S on which n array operations are performed on the set. N array operations performed on the set. Here, a system consisting of a non-empty set S on which non-empty set we have to perform n number of operations on that set. So that is called as algebraic system. Generally, algebraic system can be represented by S comma, F1 comma, F2 comma, etc. where S is nothing but non-empty set. Okay. So on that non-empty set, F1, F2, F3, F4, etc. are n array operations performed on the set. Generally, most algebraic systems which deal with n is equal to 0 and 1 and 2 operations. For example, so S comma, F1 comma, F2. So that means, S comma plus is nothing but the algebraic system consisting of n is equal to 1 operator. Okay, the algebraic system which deal with only one operation. Okay. The second case, S comma plus comma into. Here, the algebraic system which deal with two operations. Here n is equal to 1. Here n is equal to 2. Most of the algebraic systems which deal with one or two operations. Here n is equal to 1 operation. The algebraic system which deal with only one addition operation performed on the set S. Second case, the algebraic system which deal with two operations, addition and multiplication. These operations performed on the non-empty set S. So generally, algebraic system will be denoted by this one, S comma, F1 comma, F2 comma, etc. where S is the non-empty set. F1, F2, F3, etc. are n array operations on the set S. We will mostly deal with algebraic system with n is equal to 0, 1 and 2. Here n is equal to 0, 1, 2. Mostly algebraic systems which deal with no operation, with the unary operation, with the binary operation. N is equal to 0 is nothing but only non-empty set is there. There is no operation performed on the set. Yes, n is equal to 1 is nothing but only one unary operation performed on the non-empty set. Yes, n is equal to 2 is nothing but two operations that can be performed on the non-empty set. So this is the meaning of n array operation, but most of the algebraic systems deals with only one or two operations only. Next, what are the general properties of the algebraic system? Suppose we can take the algebraic system S comma plus comma star, where S is the non-empty set and plus and plus and star are the binary operations that can be performed on the non-empty set S. First property, closure property. So closure property means we can take any two elements from the non-empty set S. So that is A and B. So A comma B belongs to S. Then A plus B also belongs to S. And A star B also belongs to S. Closure property for any A comma B belongs to S. A star B also belongs to S. Like A plus B also belongs to S. So where, for example, if A comma B belongs to Z, Z is nothing but set of integers. It contains both positive elements and negative elements. So here A plus B belongs to Z and A star B belongs to Z. So this is the closure property. We can take any two elements from the set Z, so that are A and B. So it can be written as A comma B belongs to Z. Then A plus B also belongs to Z. A star B also belongs to Z. Okay, where plus and star are the binary operations of addition and multiplication. Next, second property, associative property. We can take any three elements A comma B comma C from the non-empty set S. It can be represented as A comma B comma C belongs to S. Then it satisfies this proper condition. A star B star C is equal to A star B star C. Whenever this condition is satisfied by the three elements that are taken from the non-empty set S, then plus and star operation satisfies the associative property. For example, we can take three elements from the set of integers Z. Then we have to check the addition operation is associative and the multiplication operation is associative by satisfying this condition. So A plus B plus C is equal to A plus B plus C. Whenever this condition is satisfied, we can say that addition operation is associative. Next, A star B star C is equal to A star B star C. Whenever this condition is satisfied, the multiplication operation is associative on the set S. Okay. On the set Z. Okay. Third property is commutative property. We can take any two elements from the non-empty set S. It can be represented as A comma B belongs to S. Then it satisfies the following condition. A star B is equal to B star A. Whenever this condition is satisfied, the multiplication operation is commutative. Okay. Example, we can take any two elements from the non-empty set Z. So that is A comma B belongs to Z. Then it satisfies the following condition. So A plus B is equal to B plus A. So if the condition is satisfied, the addition operation plus is commutative on the non-empty set Z. And A star B is equal to B star A. Here, if the condition is satisfied, the multiplication operation is commutative under the set Z. Okay. Next property is identity element property. Suppose we can take an element A. So that is A belongs to S. And also we can take an distinguished element that is E. E belongs to S. Okay. Then A star E is equal to E star A is equal to A. So then it satisfies this condition. So A star E is equal to E star A is equal to A, where E is called the identity element. That identity element also belongs to S under the operation star. Okay. So let us take an element A. A belongs to S. That means element A is taken from the non-empty set S. And also we can take an distinguished element, that is E. E is also taken from the non-empty set S. Therefore E belongs to S. Then it must satisfy the condition A star E is equal to E star A is equal to A. Here E is called the identity element with respect to the operation multiplication. Okay, so this is the identity element property. Okay, next example. So here 0 and 1 are the identity elements with respect to the addition operation and multiplication operation. So for addition operation, the identity element is 0. For multiplication operation, the identity element is 1. So these identity elements 0 and 1 also belongs to Z with respect to the operation addition and multiplication. Then it must for we can take any element A that is taken from the non-empty set Z, so that we can take A belongs to Z. Okay, it must satisfy these two conditions. A plus 0 is equal to 0 plus A is equal to A. Here 0 is the identity element with respect to the addition operation. Next, A star 1 is equal to 1 star A is equal to A. Here 1 is the identity element with respect to the multiplication operation. So whenever these two conditions are satisfied, then so plus operation and multiplication operation satisfies the identity element property under the set Z. Z is nothing but set of integers. Okay. Next, fifth property is inverse property. Okay. So suppose we can take an element A. So A belongs to S. That means element A is taken from the set S. So that is A belongs to S. Next, we can take another element, that is A inverse. A inverse is also belongs to S. Okay. That means we can take two elements from the non-empty set S. One is A element. So A belongs to S. We can take another element A inverse. A inverse also belongs to S. Then it must satisfy the condition A into A inverse is equal to A inverse into A is equal to E. So this is the E is called the identity element with respect to the multiplication operation. A into A inverse is equal to A inverse into A is equal to E. E is nothing but identity element with respect to the multiplication operation, where A inverse is called the inverse of A. Okay, inverse of element A. Okay, A inverse is called the inverse of element A under the operation multiplication. E is called the identity element with respect to the multiplication operation. So E is equal to 1 because identity element with respect to the multiplication operation is 1. Okay. Example, suppose we can take two elements from the non-empty set Z. So one element is A belongs to Z, and another element is A inverse belongs to Z. Okay, then A plus minus A is equal to E. Okay, so minus A is the inverse of element A. Okay, here E is nothing but identity element with respect to the operation plus. So we can write it as A plus minus A is equal to 0. Okay, so A plus minus A is equal to 0. Minus A is the inverse of A under the operation, addition operation. So therefore A plus minus A is equal to E. That means A plus minus A is equal to 0. Here 0 is nothing but identity element with respect to the operation plus. Okay. So this is the inverse element property. Same way, so A into A inverse is equal to E, where E is the identity element with respect to the operation multiplication. So that is A into A inverse is equal to 1. Because here the E is nothing but identity element with respect to the multiplication operation. That value is 1. So that A into A inverse is equal to 1. Okay. So this is the inverse property, inverse element property. Whenever these two conditions are satisfied, then we can say that element A has the inverse minus A. Element A has the inverse minus A. These two elements A and A inverse also belongs to Z. Okay. Next property is distributive property. So we can take any three elements, so A comma B comma C, from the set non-empty set S, that is represented as A comma B comma C belongs to S. Then the distributive property is A star B plus C is equal to A star B plus A star C. So for any three elements that are taken from the non-empty set A comma B comma C, it satisfies this condition A star B plus C is equal to A star B plus A star C. Here the operation star is a distributive over plus. Okay, the operation star is a distributive over the operation plus. Okay, so example, for any three elements A comma B comma C belongs to Z, so it satisfies this condition and this condition. Here this condition is the operation star is a distributive over plus. The second case, the operation plus is a distributive over star. So A star B plus C is equal to A star B plus A star C. Another one is A plus B star C is equal to A plus B star A plus C. So this is the operation plus is a distributive over the operation star. Here this is the operation star is a distributive over the operation plus. Okay, so this is the distributive property. Okay, next property is cancellation property. For any three elements A comma B comma C belongs to S and A compulsory not equal to 0. Okay, then the cancellation property is A star B is equal to A star C. So left hand side and right hand side same element A is there. We can cancel that element. The remaining elements are B equal to C. Okay. In the same way, B star A is equal to C star A. Left hand side and right hand side same elements are there. That same elements are cancelled. After that we are getting the result B is equal to C. Okay, so this is called as the cancellation property. So the cancellation property holds good for the set of integers z under the operation addition and multiplication. Okay, with respect to the addition operation, cancellation property is satisfied by this set of integers z. With respect to the multiplication operation, the cancellation property holds good for the set of integers z. Okay. Next property is idempotent property. Okay. Suppose we can take an element A. So from the non-empty set S. So then A we can write it as A belongs to S. Then A star A is equal to A. So this property is called as idempotent property. Okay, we can take an element from the non-empty set S. So it can be written as A belongs to S. Then A star A is equal to A. Okay, whatever the element you are taken, the same element is multiplied with the same element, then we are getting the same element as the result. Okay, A star A is equal to A under the operation star. In the same way, A plus A is equal to A. Here the operation is addition operation. A plus A is equal to A. We can take an element A. The same element is added with the element A. We are getting the same result. We are taken element is A. This element is multiplied with the same element. Then we are getting the result also same element. So this star operation is idempotent. Okay. Next one, we can take an element A. So that element is added with the same element. Then we are getting the result also the same element. Then it is called as idempotent property. Okay. For example, 0 belongs to Z is an idempotent element. Here we are taking an element 0. So that 0 is taken from the non-empty set Z. So under the addition operation. So here element is 0. This element is added with the same element. Then we are getting the result is also 0. Then the idempotent property is satisfied under the operation addition. Okay. Next, another example. So we are taking two elements 0 and 1 from the non-empty set Z. Okay. Under the operation multiplication. Okay. So 0 is multiplied with 0. We are getting the result is also 0. Next, 1 is multiplied with 1. We are getting the result also 1. Okay. So both are satisfies the idempotent property. So 0 and 1 elements are called as idempotent elements under the operation multiplication on the non-empty set Z. Okay. We are taking one element. This element is added or multiplied with the same element. The result is also the same element. So that is property is called as idempotent property. Okay. So these are the properties of algebraic system. Okay. So what are the properties of algebraic system that we are discussed? One is closure property, second one is associative property, third one is commutative property, fourth one is identity property, fifth one is inverse property, sixth one is distributive property, seventh one is cancellation property, and eighth one is idempotent property. So these are the general properties of algebraic system. If the closure property is satisfied by all the algebraic structures, closure and associative property is satisfied, then it is called as a semigroup. Closure, associative, identity property is satisfied, then it is called as a monoid. Closure, associative, identity and inverse properties are satisfied, then it is called as a group. Closure, associative, identity, inverse and commutative property, then it is called as abelian group or a commutative group. Okay. So thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name. So Divvela Srinivasa. Thank you.